All right, we're recording. Welcome everybody back to another conversation with the TLC. But before we kick off, I've got a few really exciting announcements. So let's get started. First off, I think most people know about the TLC learning groups. And we've got a repeat of the first TLC learning group that we got started. And it's with Ken Williams. And Ken, you're here. Do you want to tell about it first?
Yeah, definitely. So this course is for people who they're familiar with GA, but they are not really confident in BigQuery. So we just wrapped up the first round of it. It was a raving success, if I can say that myself. And
Sure, I think you can.
yeah, we're doing
We
it
got good
again.
feedback.
We're gonna do it in September. This time it's gonna be over 4 weeks, 3 hours a week, two 1.5 hour sessions. We cover everything, and at the end of it, you'll have a working data model, which is actually launched in a tool called Dataform that takes your yesterday's data and it prepares it so that you can do all kinds of great stuff, but at least send it off to a BI tool, do different types of analysis, maybe even send that data off to a media mix model. So we'll see how you feel about that after today, maybe. So
Awesome.
anyway, hopefully you guys can join if you haven't already seen that info.
So if you got questions about it, reach out to Ken. You can go to bit.ly prep GA or use that QR code to sign up. And that is starting September 10th. And then brand new learning group launching September 30th with myself and Ruben DeBoer, award-winning educator. And we will be teaching about experimentation cultures and how to build an award-winning experimentation culture. Online Dialogue has been teaching this course for years, and companies that take this course have been winning the Experimentation Culture Year awards for like 10 years. It's a real, or I guess the Experimentation Culture Awards have been around for 5 years and they keep winning. So I reached out to Ruben and said, hey, how do we get this training to the US and more broadly around the world? Because only the Netherlands is winning. And so we found out a way that we could basically make this course available online. And sneak peek, we're also going to do kind of a world tour, and we're going to bring this course in person to companies that are interested. So if you're interested in bringing the course to your company, reach out. We can talk about that. If you want to take the cohort version of the course, we're starting at September 30th. So that's bit.ly at AB culture or this QR code. All right. Last, big news. Start by thanking Conductrix. They've been with us from the beginning. Thank you, Matt, Nate, Ezekiel, and the full team at Conductrix. And we'd also like to welcome our new TLC sponsor, Convert. Thank you so much. And thank you to our TLC Connector newsletter sponsor, EPO, and our brand new sponsor starting this month with the newsletter, Growth Book. Thank you, Graham, for being here. We really appreciate it. And thank you, Eddie Aguilar and Blazing Growth. All right, I'm going to stop sharing and pass it over to you, Jim. And Sonny, take it away.
Yes, thank you, Kelly. This is so exciting. Thank you for having me here. Thank you for giving me the opportunity to host this TLC session. Like, what's the official name? And let me announce the session properly. So, should I wait? I don't hear you, Kelly.
Let me take the screen share back, Jim, so that he can
Yes.
introduce you.
I have the prompter, Kelly. So, Jim Gianoglio is the founder of Causal Analytics, a consultancy with a singular passion for unraveling the enigmatic world of marketing mix modeling. He is at the forefront of the industry, collaborating closely with a diverse range of clients to quantifiably demonstrate the impact of marketing efforts. With more than 15 years as a trusted consultant in the digital and marketing analytics realm, Jim brings a wealth of expertise to the table. As a leader in the marketing measurement space, he shares his knowledge freely through his MMM Hub newsletter and Slack group, and as a co-host of the Measure Up podcast. And speaking of podcasting, Jim has an unfair advantage because in his previous life, he used to do voiceover for TV commercials. Like that is a leg up, if anything is. He also biked, like pedaled from Pittsburgh to Washington, D.C. in 2 days. That's 333 miles in America. Here in Europe, that's a lot. I don't know exactly how long that is. He also roasts his own coffee for fun, which is pretty cool. And I want to talk to him about this after this session. So crashing the TLC stage to help you stop treating your marketing channels like a box of chocolates, never knowing what you're going to get, and to talk to you about mastering modern marketing mix modeling, aka Jim Gianoglio, take the stage.
Awesome. Thank you, Sonny. I cannot share a screen while others participate. Sorry. There we go. Awesome. Thank you. So yeah, thank you, Sonny. Thanks for inviting me to come speak, Kelly. I'm always happy to talk about geeky topics like modeling and testing and all the good stuff that goes along with it. So let's get right into it. I like big data, and I cannot lie. I also like small data, big data, any data. Give me whatever data you have, and I'll find something to do with it. Really quickly, the things that we want to go over today about marketing mix modeling, give you an understanding of what it is. If you've maybe heard it, but not quite sure what is it, some kind of black box stuff, or if it's some kind of statistics, or if it's, what actually is happening under the hood here. We'll look at how it works with the data that's required, what questions you can answer with it, and what questions you can't answer with it, because there's no silver bullet in our industry, unfortunately. And then leave you with some resources for continuing learning about MMM if you're interested. All right, so what is MMM? Well, hold on, it's MMMs, not M and M. So just to kind of clear off that confusion. Also, it's not the first three letters of this terrific 90s era pop rock song from brothers Isaac Taylor and Zach Hansen. It's not that one. It's this one. It's marketing mix modeling, right? Or you might have heard the term media mix modeling, or even econometrics, right? These are all basically the same thing, different terms for the same thing. They refer to some form of statistical modeling that tries to explain or capture the underlying relationship between our marketing efforts and their effects, namely revenue or profit or leads or conversions, whatever that thing that is important to us that we're trying to understand more about. It is just a model, right? And so we have to remember the famous words from the British statistician George Box. All models are wrong, but some are useful. And that's exactly the same with marketing mix models. They are not perfect truth. It's literally just a mathematical function that we give it a bunch of X's and it spits out a Y. So it doesn't have any kind of prescience or anything like that. Another way I like to explain marketing mix modeling is that it's a tool for finding patterns in the data, right? And so, for example, I could show you this chart here, and literally in less than half a second, I'm sure you could pretty quickly say, oh, there seems to be a relationship between how much we spend in media and the revenue we get. And clearly it looks like when we spend more in media, our revenue goes up, and when we spend less, revenue goes down. You could even maybe look a little bit closer and say that it looks like there's a little bit of a lagged effect. So when we immediately dropped our spend, the revenue stayed up a little bit, and then it kind of came back down. So very quickly, again, less than half a second, we all kind of saw this and we were able to see this relationship. And that's, in essence, that's what we're doing with marketing mix modeling. We're looking for relationships between, we spend a little bit more in this channel, what happens to revenue? We spend less in this channel, what happens to revenue? That's what's happening under the hood. And as humans, visually, we're very good at doing this. Sometimes a little bit too good. We find patterns that don't actually exist, like the per capita consumption of margarine correlating with the divorce rate in Maine, or the popularity of the first name Annabelle that correlates with UFO sightings in Maryland. Or my personal favorite, Google searches for "why do I have green poop?" which is inversely correlated with solar power generated in Bulgaria. I'm not sure how I can explain that one, but clearly they're tightly integrated there. These are all from Spurious Correlations, Tyler Vegan's website there. Fun things to look at. So yes, we're good pattern seekers by nature, but we need a little bit more sophisticated way of doing this. So this is where marketing mix modeling comes in. But intuitively, again, that's what's happening, right? We're just looking for, changes in spend and how does that impact changes in revenue. So let's take a look at a really very stupidly simple example here to kind of drive home the point here. So imagine I start a new company today. It's brand new. No one's ever heard of it before, but I just launched today, and I haven't spent any money on any kind of ads, and my revenue is $0 because nobody knows about me. I'm unknown to everybody. So I have this idea. Maybe if I spend some money in Facebook ads, I'll get the word out and people might start buying from me. So, I spend $25 in Facebook ads, and lo and behold, I get $50 in revenue that day. And I think, okay, well, let's try more. What if we spend $50 in Facebook ads, and lo and behold, I get $100 in revenue. And I think, okay, this is going well. Let's try $75, and I spend $75 and I get $150 in revenue. And apparently Matt Gershoff likes margarine. I'm not sure if he meant margarine or margins, but either way, they're both good. So, clearly we start to see this pattern happening, right? I'm spending money in Facebook ads and I'm getting revenue coming through, and, a brand new business. So very clearly it must be the Facebook ads that are kind of driving this cause and effect here. So the question then becomes, at a certain point, you have to ask, like, well, what happens if I spend $100 in Facebook ads? Am I going to get $100 in revenue? Am I going to get 300? Am I going to get 200? What's the amount of revenue I should expect from that? And if I ask you with this very simple example where clearly, we have one channel of marketing and 4 data points, which is not a lot of data points, but if I asked anyone on this call, how much revenue would you expect if you spent $100 on Facebook ads? Given this very small data set of 4 data points, I'm sure you could probably come up with an answer that seems pretty plausible. Feel free to type in the Slack group, the TLC calls channel, your answer to this question. Would you expect $50, $200, $10,000, $0, whatever Facebook says? Any thoughts on what you would expect if you spent $100 in this example? I see some people typing 200. Kelly's putting her bid in for $200. I see B, $200. I see some good answers here. Okay. No one's guessing E. That's good. Okay. Yeah. So obviously very, very simple example. I think everyone is going to get the right answer here. $200, right? Now, so $200. So we have a graph here. We have Facebook spend on the x-axis. Let's call that X, right? And we have revenues on the y-axis. We'll call that Y. And it seems in this example that revenue is a function of how much we spend in Facebook. So in other words, when we multiply our Facebook spend by 2, we get the revenue that happened on that day. So a simple mathematical equation here, right? Y equals 2X. So we can, if this equation truly captures the underlying dynamics of the market, we would expect to be able to substitute any value for X, our Facebook spend, and it would accurately tell us how much revenue to expect given that level of investment. So I now have a mathematical equation to say, well, if I spend $1,000 in Facebook ads, I should expect $2,000 in revenue. Wouldn't it be great if that were true, right? If we could just double our spend, add, to infinity, and just, make a lot of money and go home and sit on the beach. So this, I would say, is quite possibly like the most simplest marketing mix model that you could ever see, right? Y equals 2X. That's all it is. It's just a mathematical equation. But some of you are going to say, wait a minute, clearly this can't be it, right? Like that's never going to fly. This doesn't pass muster. And I would say, yeah, sure. If your business has been around for a while, you could shut off all of your marketing today and you're still going to have some sales. You have some baseline revenue coming in that's not directly caused by your marketing. And so that's easy enough to account for, right? We can just add an additional parameter to this function. So we just add our baseline sales in here. Now we have Y equals 2X plus 50. So $50 of baseline sales. So if we spend $0 in Facebook ads, maybe we get $50 in revenue. And then if we spend $25, we get our baseline of $50 plus twice our spend, which is another $50. It adds up to $100. So we have something here that's starting to look familiar to our early high school or maybe middle school years, which is the equation of a line. Y equals mx plus b. my daughter just recently was learning this in her algebra classes, and so I got to pull her in to actually this presentation when I was originally creating it, and she had a lot to say about this. But this is what we're talking about, right? Simple linear equation, y equals mx plus b. In this case, m is the slope, that's 2. So our slope of this line is 2. Our y-intercept is b, that's $50. And when we start to kind of translate this into MMM speak, some of the terms you'll hear, y is revenue, that's our dependent variable. X is our Facebook spend, that's our independent variable. And when we think about slope, we often call that our coefficient or our ROI. And the y-intercept, B, is our baseline revenue. All right, just want to make sure everyone's still paying attention. Okay, GA4, better than everyone agrees? Okay, well, make sure there's no questions, okay? So clearly, y equals mx plus b, very simple. This example, again, stupidly simple example, doesn't actually reflect any reality that we live in. So we have to start to try to capture the actual reality, or what we believe to be the reality around marketing and how it works. And one of the things that we need to account for is something called diminishing returns. So in that past example, there was a strictly linear relationship between how much we spent in Facebook and our revenue. Obviously, like I said, if we could just double our spend to infinity, then we wouldn't be here talking about this. We would be extremely wealthy and living in a yacht somewhere. But diminishing returns is real. So the more we spend in a channel, the less efficient it becomes. So in this example here, the first $25 of spend might have an ROI of 2. We might get $50 in revenue. And then the next $20 of spend probably isn't going to be as efficient. Instead of getting $50 back from that second $25, we might only get, an extra, $40 or $35 out of that. And it just keeps getting less and less efficient the more we spend in a channel. And so this is something that we need to account for in this model that we're building. The second thing that we need to account for is something called ad stock. And ad stock has two sort of related and overlapping components. One is lag. And the lagged effect is basically the idea that there may be some delayed response from our advertising, especially for non-impulse buys. For example, earlier this week, I saw a TV commercial for a new pizza place that just opened up about a mile from where I live. And guess what? Tonight we're having pizza. So that TV commercial that I saw on Tuesday is having an impact on Friday, right? So there's a few days lagged between when I saw it and when the results of that came to fruition. Similar to that is decay rate. So the decay rate kind of reflects the idea that the impact of an ad diminishes over time. So there might be certain types of ads, like bottom of funnel, demand capture type of ads, that only have an immediate impact with very little residual impact. So think of things like branded paid search, right? It's unlikely that seeing someone's branded paid search ad will stick in the customer's mind for days or weeks to come, causing them to eventually come back and buy. But other types of ads or channels, like TV, for example, may have a more lasting impact. So especially if it's brand awareness or upper funnel awareness campaigns, where the goal is to increase awareness of the brand or consideration when the customer is eventually ready to buy, those types of advertising initiatives tend to have a longer decay rate. All right. And kind of the third thing that we need to also account for is, we're probably spending in more than just Facebook ads. We probably have a lot of different channels that we're spending in. So it's not just y equals mx plus b, it's y equals beta A plus beta B plus beta C plus as many channels as we have, or as many features that we want to include, plus our baseline revenue. So we might have Facebook and Google ads and CTV and Spotify. We might have out of home, like billboards or bus shelter ads. We might have point of sale displays. We might have direct mail. We might have print ads. There's a lot of different ads that we want to account for here. So our simple, nice y equals mx plus b equation ends up looking something a little bit more like this. So we have our our ad stock and our diminishing returns kind of wrapped up in here into this little bluish grayish box. We have other things that we haven't talked about, like seasonality or holidays or general trends that can be accounted for as well. And this documentation is actually from it's used by Meta's open source MMM package called Robin. So this is the actual the equation from their documentation. This is how they model for marketing mix modeling, and this is using ridge regression. So when you think about it in terms of, oh, we're just looking at how changes in our spend affect changes in our revenue, that's a good intuitive understanding of it. Y equals mx plus b, still a good intuitive understanding of what we're looking at. But it does get a little bit more complicated or complex. We can really try to model things as close to possible as what's actually happening in the data generation process. Okay. What about the data? So we have a good intuitive understanding of what marketing mix modeling is doing. What kind of data do we need to feed into this? And this is the part where I love talking with people who are so used to the past 10, 15 years of last click attribution or multi-touch attribution, where we need to track all of the interactions a user has with our advertising and be able to connect all of the dots together to this one individual user, which has obviously become very difficult now with privacy regulations, with changes that Apple's making, with consent mode and people not accepting cookies. All of that fun stuff makes it really hard to connect all of the dots to a single person, a single user. But with marketing mix modeling, we don't care about any of that. We don't need user level data at all. It's all aggregated data. And it's quite simply daily revenue and daily spend in the channels that you're modeling. You could also throw in impressions depending on how you're modeling it. Some people will use spend as their independent variables. Some people will use impressions. Some people will use both of them. But it's simple as this, right? We have a column for a CSV file with a column for date. Typically, we want the daily level. You can model at the weekly level if you can't get it down to the daily granularity, but it's always better to get it daily if you have it, because then you can always model it daily and you can always roll it up weekly if you need to. So daily data, we need revenue, and then again, impressions and spend per channel. Some channels may not have spend. So email, you might just be looking at the number of emails that you've sent per day. But generally, the data itself is not complex. That's not to say that it's easy to get. I have worked with many clients where they, despite spending $50 million a year in ads, they have to go into Facebook and manually download the data from there, and then go into Google Ads and manually download the data from there. It's surprising how some companies just don't already have a data warehouse nicely put together, but that's the real world. All right, so the data is pretty simple. We can hook up Fivetran to BigQuery, get all of our data together, and go off and running. So we can just get rid of multi-touch attribution or last click attribution now, right? Let's take a breather. Let's take a beat here and talk about what we can do with marketing mix modeling and what we can't do. So marketing mix modeling is really useful for having a higher level understanding of our marketing performance and for making budget allocation decisions. Okay. So that's generally where we're kind of the world where we're living in. We're not looking at the super granular level. We're not making day-to-day decisions, but generally what I talk about the kinds of questions that marketing mix modeling can answer, I bucket them into these sort of three buckets. So it's questions around budget, questions around incrementality, and then diminishing returns. So around the budget, we can ask questions like, how should I allocate my marketing budget to optimize conversions? Right? Should I be spending more in this channel or less in that channel? What's the right level of allocation for all of my channels, or even some tactics within a channel, like, with sort of current capabilities around marketing mix modeling, we're often not just saying, okay, I have TV, radio, and digital as my channels, right? That's sort of this kind of stale impression of what marketing mix modeling used to do. It'd be like, oh, digital is a channel. But really what we're doing is looking at digital and we're saying, well, we have Facebook, we have Google paid search, we have TikTok, we have Snapchat, we have email, and even going a level beneath that, right? We want to know within Google, I want to know how branded paid search versus non-branded paid search is. Within Facebook, I want to know how my prospecting versus my remarketing is working. So you can go even a level deep. Can't go too much deeper than that, but that's the kind of level that we would want to look at. If I have extra marketing budget, where should I invest it? What's the channel that has the most room for growth, right? Or alternatively, if I need to cut budget, which channels should be reduced and by how much? That's the world that we've been living in for the past, year and a half with interest rates going up and money's not free anymore, and companies are starting to have to actually be profitable, which is crazy thought. They can't just spend money for growth at the expense of profit anymore. So yeah, we need to know how much each channel can be reduced and what's the effect of that. Incremental revenue. So this is one that's great for marketing mix modeling and kind of an advantage over something like multi-touch attribution, which is that, multi-touch attribution takes all of our revenue or all of our sales, all of our conversions, and says, okay, what were the marketing channels that happened before that? And then we're just going to kind of give credit to the channels that came before it, regardless of whether or not those channels actually influenced the sale. But with marketing mix modeling, we get that baseline revenue as one of the outputs, right? It's going to tell us, here's how much each channel contributed to your revenue, to your sales. And here's how much revenue was just baseline. It's you would have gotten it in the absence of marketing. So in that sense, it's truly incremental revenue per channel, not just trying to backwards map our sales to what happened before it. So we can ask questions like, how many conversions did each channel actually drive? Not just, Google claimed credit for that sale because they happened to see the paid search ad for your brand. Right? What's the incremental ROI of each channel? And if I increase spend in channel X, how many more conversions will that drive? So these are all questions around kind of getting to the actual contribution of our channels versus sort of an attribution mentality. And finally, we like to look at diminishing returns. So what's the marginal ROI of each channel? What's the efficiency of the last dollar in that channel? So a lot of times marketers will look at the ROI of a channel for the entire spend, and they say, okay, the ROI is 1.8, so I guess it's profitable. But what they may not realize is that, overall, the average ROI for that entire spend is 1.8, but the return on the last dollars in might be 1.2, and that channel may no longer be profitable at that last dollar in. So this is where we can start to understand the marginal ROI of the channels. We can understand if we've reached that level of diminishing returns in a channel where it's no longer worth putting in additional money, or if we have room to spend up in a channel and still have that positive ROI. All right. So knowing when not to use MMM and the kinds of questions that it won't help you with, or that we need to be a little bit more cautious around, is also really important because, again, there's no silver bullet in marketing analytics or marketing science or marketing mix modeling. It's not going to be the best solution for every question or for every situation. And again, sort of 3 buckets to think about here: too little, too granular, or too long. So if there's too little spend, right? If you're spending less than $1 million to $2 million a year in advertising, you're probably not going to get enough value out of a marketing mix model to make it worth it. Some people put this number a little bit higher. 5 million is a common sort of benchmark. If you're spending at least 5 million a year, then you're probably safe to do marketing mix modeling and assume that you'll get value out of it. I've seen cases where, yeah, less than $1 million a year, it gets really hard, but I put that number around 1 to 2 million a year in ad spend is kind of where you want to start thinking about MMM. Also, if you have too few channels, right? If all you're doing is marketing on Google ads and Facebook and maybe Instagram, you don't need a model to tell you what's working and what's not. You can kind of make some changes and see what happens. It's not that complex of a mix to really need a model to help you understand where to shift your budget. Also, if there's too little variability, and this leads into a common challenge for marketing mix modeling around collinearity, which is if you don't vary the spend in your channels a lot. So if you tend to always increase spend in all channels at the same time or decrease spend in all channels at the same time, for example, Black Friday, Cyber Monday, all of your channels get increased budget. Or if there's, if your marketing budget gets cut and you need to cut 20% across the board and you just drop all of them by 20%. Again, that's not giving the model enough variability to understand what's happening. So that's just something to kind of be mindful of. All right. Granularity, right? So marketing mix modeling, like I mentioned, is good for understanding high level performance of marketing channels, but not at the daily level, right? Your channel managers aren't going to be going into Google Ads or Meta Ads manager and making changes day by day or week by week based on the model. They're also not going to be able to do this at the keyword or ad group level of performance. It's generally going to be a level above that, maybe at the campaign level or the tactic level. And generally speaking, you're not going to be using MMM for understanding creative or messaging performance, like which ad performed better. Was it the one with the blue background or the red background, or was it the video, the user generated content, or the polished, photo shot in a studio? That's really not the kind of thing that MMM is going to help you with. That's something that you would want to do with testing. And finally, this picture always freaks me out, but if it's too long, so too long of a sales cycle, for example, if you have a high priced considered purchase, or if you're in a B2B or account-based marketing situation, I put this in here, but also hesitate because these don't necessarily mean that you can't use MMM. It just means that you may have to do something a little bit different. You might have to get a little creative and be really cautious about how you model it. For example, with some B2B, you just may not have enough volume of sales to really get a read on what's happening. Or if you do trade show marketing, you might go to 2 or 3 trade shows a year. Well, if you have 2 years worth of data, that gives you, 4 to 6 data points to work with if you're attending a trade show. So it's really hard to kind of directly map that. But the things that you can do in these situations where it's, again, like high price or considered purchase, would be to look at micro conversions. Universities are a common example, right? You don't think of where you want to go to school and apply and get in and actually start classes tends to take a while. And so, using actual matriculation as your metric, as your dependent variable, probably not a great idea, but you could look at applications, or you could look at leads on the website, how many people submitted a form for more information. Those are the kinds of things that you have a little bit more volume and you can see a little bit more direct impact from your marketing on that. All right. So some resources for getting started, and then we'll probably have some time for questions. So that's good. This is a great YouTube channel from Mass Analytics. Dr. Rama Girar, she was actually on our podcast a while back. Really, really smart, has some really good things to say, really good framework for thinking about marketing mix modeling. And she has Mass Analytics has a YouTube channel where they have a whole masterclass on marketing mix. So everything from basic to intermediate to advanced topics are covered really, really well there. We have the MMM Hub Slack group, which you can get to if you go to mmmhub.org/Slack. Sign up for it there. A lot of really smart people talking about really technical topics, really in the weeds, statistical questions. Also, people who are sort of new to marketing mix modeling and just trying to get an understanding of what's going on there. There's also the newsletter that I have, and I'm trying to get back on board with weekly updates on that. But if you want to, give me your email address, I'll occasionally send an email newsletter out with some resources for MMM and testing and other marketing analytics related content. And this is a new one. Recast is a vendor. It's a platform, a marketing mix modeling platform. I think that they probably have the most robust, I hate to say sophisticated, but probably the best marketing mix model out there of vendors. They've put a ton of R&D into building out the framework that they use for marketing mix modeling. So it's a really good tool, but even better than that, the co-founders, Michael Kaminsky and Tom Vladeck, are just fountains of great knowledge, and they like to share that everywhere they can on LinkedIn and on Twitter, and in this new part of their website that they just launched. It's MMM Academy. So they've basically kind of organized all of the content that they've put out into this section of their website. It's a really great resource that I wish existed back when I got started. So they have everything from white papers on operationalizing MMM to videos to blog posts, everything kind of nicely organized there. So that's a really good resource that I've been pointing people to. And then some really fun ones. So I was in a webinar a while back where the goal was to try to build a marketing mix modeling framework that would be applicable to any data set from any company. And as part of that, the company that was hosting this, Conjura, put together a data set of 100 different companies' data. It's all anonymized, but you get things like what industry they're in, what category they're in, and you get their spend and all of the channels that they spend in and their revenue. And it's for 100 different companies. And this data is there for anyone. It's a public data set. Go to bit.ly/MMM-dataset, and you can download that data. So if you want to try, play around with some models and try your hand at this, but you don't have any data, well, now you do. So you can go download that data, and the link is in the Slack channel. Thanks, Kelly. So yeah, it's just a really good place to get a bunch of data and play around with this. And of course, we've been talking high level about MMM and kind of what it is and how it works. But one of the great things that's been happening in the past 3, 4, 5 years is that there have been a lot of efforts around open sourcing frameworks for doing MMM. Whereas before you'd kind of have to go into R or Python or whatever your modeling language of choice is and kind of build your own model from scratch and have to kind of like work through all of those transformations around ad stock and hill function for saturation curves, things like that. But Meta put out their version of open source marketing mix modeling package called Robin. That was just over 3 years ago. It seems like a lot longer than that, but it's probably the most common package for marketing mix modeling. It's been around, I think, the longest. Has probably the best documentation out there of any of them that are out there. It has a really good group of people that can help out with it. There's also the other one that I would mention is PyMC marketing. So I guess a couple things. So Robin is based in R. So if you like R, like me, yeah, good. If you like Python, sorry, it does have a Python wrapper API, but it's basically an R package. PyMC is, the other thing, Robin is frequentist framework, whereas PyMC is Bayesian. I know we didn't get into the whole frequentist versus Bayesian, but a lot of the more the way that things seem to be going in terms of better performance and the types of modeling frameworks that make the most sense tends to be going towards Bayesian frameworks. So the PyMC open source package or library is a really good Python library that is Bayesian. Also has a lot of contributors around this. They've been putting a lot of good content, and they've been making a lot of updates to this library over the past 6 months. So it's really interesting to see what's happening there. I don't have a slide for this, but also maybe people have heard that Google put out their officially supported open source marketing mix modeling library called Meridian. What was that? Maybe a month and a half ago, 2 months ago. It's it's open source, but it's closed access. So they're slowly giving people access to it. And it's based off of a library called Lightweight MMM, which they open sourced a while back. It just was never officially supported. Also, that is a Bayesian framework, and it's in Python. So you have some options there. And with that, I will leave some time for questions.
Thank you, Jim. This was amazing. So about these companies releasing their models, and I'll ask the first question. Why are they doing this?
I've thought about this. Like, what's the incentive for Facebook to have an open source solution, and why would Google give an open source solution? And I think I don't have any insider knowledge here. I don't know anyone directly. I've never talked to the folks at either of those that have put them out. But my hunch is that it's because they don't want people to say, oh, well, you're just obviously going to bias it towards Facebook, or you're going to bias it towards Google. And it's funny, like even with Robin, I've seen the threads and LinkedIn where people are saying, oh yeah, Robin is just going to tell you to spend more on Facebook. I'm like, it's an open source model. You can see exactly what's happening in the code. It's not doing that. So maybe that's the reason. I don't know. I think the reason that we're seeing more activity in general around MMM is around privacy regulations and the changes that Apple has made around, iOS 14.5 and ITP and ATT and all that kind of fun stuff, basically decimating our ability to track at the user level, and sort of just understanding that there needs to be a better way to understand this sort of cross-channel optimization.
That makes perfect. I mean, this reminds me of React versus Angular back in the day when I was a developer. Like, why would they do this, and like, why do they want to see? So it's kind of similar there, at least to me. As our audience is typing their question and unmuting themselves to ask, I will ask you, Jim, to let us know where you will share the slides if you can.
Oh, sure. I can. I'll send out the link to the Google Slides. That's probably the easiest way.
Perfect. Yep. So, does anyone have a question? TLC calls channel, Zoom chat, whatever works for you, or just unmute yourself. I'll start naming names. Like, I see the list of attendees and participants. I'll start asking you questions if I don't get at least one question.
I see Matt putting in some commentary in the channel. So talking about how Robin uses ridge regressions. Yeah, that was sort of a conscious decision to use ridge instead of lasso, because lasso tends to zero out your channels, or the effect of the channels. And so that doesn't tend to make sense in marketing mix modeling, because if you have a model that just says, oh, these channels don't have any effect at all, it's probably not the case. And businesses have a hard time swallowing that. So the ridge regression is nice because it doesn't just sort of zero out the channels. It'll just reduce the effect or the impact.
Right, and we have an incoming question. So Florent is typing something. So let's just wait a little bit.
While Florent is typing, I'm just going to remind some folks about upcoming events. In a few weeks, we have Ruben coming back to chat with us about meta-analyses for better learning prioritization and stakeholder alignment. So that's Ruben DeBoer. And then August 16th, we have Jim Stern. He'll be talking to us about generative AI, a strategic power tool, imagination engine. That was his talk from Marketing Analytics Summit. So anybody who caught that talk, it was really amazing. So that will be August 2nd and 16th. And then if you aren't, if you don't have a copy of the TLC Experimentation Events Budget Guide, I will put that in the Zoom chat and again on the TLC Calls channel because it's just been updated. The code MIT is they've just announced the dates, October 18th and 19th. So anybody who wants to go to Code MIT, they have announced the dates and early bird registration through September 30th. So anybody interested in Code MIT, that registration is now open. And Experimentation Island, organized by the TLC, registration is going to open this month. So pay attention, get on the list.
And we
and
have
I'll
some
pass it to you,
questions.
Sonny.
And we have some questions. So Florence' question is, your presentation touched on the optimal approach. Can you speak to the limitation introduced by clients being difficult? Whatever that means, refusing to introduce some variability in their spend, HIPAA override, not trusting the results, and that sort of things.
Yeah. So, couple of questions in there, actually. Yeah, clients are going to be difficult. I would say if they don't want to introduce variability, or they don't trust the results, or the HIPPO, the highest paid person's opinion, is different. They say, well, I know I spend this much money in newspaper ads. It's got to be for something. Like, I feel like maybe this is just sort of my perspective, because I tend to deal with the clients that are coming to me knowing they already have a problem. So if I would never, this is maybe a cop-out answer, but if a client is going to be that difficult, they probably aren't going to spend money on a MMM to begin with. They're just going to be stuck in their ways and go back to last click modeling and, go with that. But it does introduce a good point, which is you have to be willing to take action on what the model is showing you, right? Like, if you're not doing that, then you're wasting your money on the model. Like, it's not like, oh, we spent, $100,000 on this marketing mix modeling project, and we got all this output, and now we know so much more. It's like, well, the whole point of it is so that you can increase your spend in this channel and decrease your spend in this channel, and hopefully the net result is that you make more money overall. So if you're not willing to do that, then it's kind of a pointless exercise, right? Just maybe it feels good to do that, or the CEO can say to his board that, yes, we do beta-driven marketing, but hopefully you're actually taking some action. That action doesn't necessarily have to be like, well, the model told us to do this, so we did it. The action could be, well, the model thinks Facebook prospecting has an ROI of 6, but Facebook and the platform only says the ROI is 0.5. Like, what's going on here? Well, let's test it. Let's build a GeoLift experiment, randomized controlled trial, conversion lift study, whatever is the best fit for you and your company, and let's test it and see who's right. Because generally, there's a framework from a guy named Ben Dutter over at Power Digital that I've stolen, and I love it. It's called the Beats framework. And it's basically, we have a lot of different signals, a lot of different data that we can look at that sort of hint at how our marketing is performing. But not all of it is as trustworthy as everything, right? So you might have your multi-touch attribution saying the channel of this is whatever, and so you can take that with a grain of salt. But then you have your marketing mix model that says it's this, and it's like, okay, I'm going to believe the model over the MTA. But then you run a test and it says something else, so I'm going to believe the test over the model, right? So you have this sort of hierarchy of data points that you're more likely to believe. Sorry, I feel like I just rambled on for a while. Sorry.
Not at all, not at all. So we have 2 more questions that came in on Zoom, but use TLC calls channel and Slack, please, everybody, because we lose the Zoom questions when the call is over. That's why. The first one is from Matthew. Any thoughts around MMM for multi-location healthcare providers?
Multi-location healthcare providers. Yes. So you can certainly do modeling at, location level. So there's, hierarchical modeling approaches where you can basically have sort of models at all of the individual location levels, and they kind of get rolled up into sort of a national level model, or a higher geographic level model. But the thing to keep in mind too is, how does that help on the marketing side, right? If your marketing spend is just national, And the levers that you're pulling are, we're spending this much in this channel, and Facebook decides where it goes, or do you actually have campaigns for each location individually? So I have one client that has 32 locations in the US, and they actually do have different campaigns per location. And so they're spending differently in Cleveland than they are in Las Vegas, for example. So, and that's a case where, yeah, you'd probably want to do more location specific, maybe roll that up into an overall model to get kind of high level performance metrics and recommendations. But you can definitely do that at the location level.
Thank you. We have another one from Zoom, and then we have a question from Matt Kirshop in TLC
Oh,
Call Channel.
no.
Oh yeah,
It's going to be a hard question.
I'll need to read a lot of text just to get you ready. The first question from David is, what do you recommend for a middle ground between an MMM and daily optimizations?
Yeah, so that's a great question. And this is where I've been spending a lot of time trying to better understand the needs of the marketer, because I've spent most of my life sort of in the analytics and data science side, and kind of, the marketers were like next door to my cubicle, and I could kind of talk with them and ask them some questions, but I'm not the marketing expert. So I don't understand the ins and outs of their daily work, like what they actually do and how their channels work. So when you're thinking about sort of the daily level optimizations that a channel manager is going to make, they're looking at, how's this channel performing? How's this campaign performing? How is this new creative performing? And they're looking at things like ROAS or CPM or CPC within the platform itself. And so whenever you're looking at like ROAS within Meta, the number that it's spitting out, that number is wrong, but you don't know by how much and in what direction. So this is where you can use a model to help inform that, right? So if Facebook says the ROAS is 2, but the model says the ROAS is 6, you can apply a multiplier to whatever you see in Facebook and just have that in mind. So it gives you a sense to sort of still use the platform metrics on a daily level to make decisions, but sort of applying a multiplier to them so you kind of get a little bit better sense of actually what's working, what's not.
Perfect. The questions are flying in, by the way. So if any one of you wants to unmute yourself and ask the question directly, like Matt, Peter, Kelly, I will give you a chance to do that. Otherwise, I'm reading anything that's on this prompter today. Yes? No? Okay. Matt's question, how do you estimate, no microphone, okay. How do you estimate variance in the output? And more importantly, how do you discuss and explain those estimates? For example, in a simple linear model, one might generate a prediction interval. Let's stay in the frequentist land. Is there an analog here for most of these approaches? And if there is, how often will those intervals allow for support for almost any arbitrary policy? ? Attitude. I read everything.
Okay, let me see. So one way, and I'll speak to the one that I know the most about, which is Robin. It's the framework that I use. It's what I kind of first got started with, and I just know it the best. So it's the one that I use, and so I can kind of speak most directly to that one. The way that Robin handles, and maybe I think I understand the question, but the variance in the output, basically the uncertainty in the model, is when you run the modeling framework, Robin is actually building thousands of models, right? And it uses Nevergrad to optimize your hyperparameters, which is Nevergrad is another open source meta library that does multi-objective optimization. So it's optimizing the hyperparameters to achieve the best normalized root mean squared error of the model, plus another metric, which is what they've called decomp RSSD. In essence, it's a way to say, like, we want to make sure that the level of spend in a channel and the contribution of that channel aren't too far off. So we don't want to say that we spend 1% in this channel and it has 99% of the effect, because that's just not believable from a business perspective. So it's basically optimizing towards those, but it's doing those in a way that, like, it chooses some hyperparameters, sees what the performance is, then keeps trying to optimize that, and you end up with 50,000, 75,000, 100,000 actual models, most of which are garbage, but maybe 1,000 of them are all pretty close in terms of their performance in terms of normalized root mean squared error and the decomp RSSD. all of this is a really long-winded to say, winded answer, which is at the end, it kind of gives you, let's say, the top 10 models. But it clusters those 1,000 models into clusters based on how similar they are. And when it gives you the top 10 models, it says, okay, here's a model, and all the other models in that cluster had the ROI for this channel between this range and this range. So it gives you, I mean, they call it a confidence interval. I don't know if it's really a confidence interval, but it gives you a sense of, this one single model, this hero model, says the ROI is 5, but all of the other models in that cluster of models that it's close to have it between 4 and 7. So it gives you a level of how much the other models that are similar to it agree on that channel. And so what you find is that there are certain channels, if you don't spend a lot of money in a channel, or if there's a lot of variance in a channel, there's going to be a large range for the ROI in that channel with all of the clusters. So it gives you, again, sorry, long-winded answer. It gives you a confidence interval that way. Bayesian models do it completely differently. That give you a credible interval based on the output. Again, less familiar with that approach, but I don't know if I answered his question or if there were other questions in there too.
This is amazing. Sonny, thank you. Jim, thank you. I'm going to ask Jim, Sonny, everybody to continue the conversation over on the Slack because we're at time, and I think we're losing folks because we're at time, but also people still have questions. So if you're willing, Jim, let's continue the conversation, but let's do it on Slack. Sonny, thank you so much. Jim,
Thank you so
thank
much.
you. Thank you, everybody, for having your wonderful questions. And I hope everybody has a wonderful weekend. I will start the recording, start uploading the recording on YouTube. And I hope everybody has a great weekend. Thank you so much.
Thanks,
Bye.
everyone.